Hello everyone, the topic of the briefing today is novel lightweight high-performance heterogeneous structure medium entropy alloys. In this topic, the series of titanium-rich medium entropy alloys were exploited to pursue the outstanding mechanical properties and potential in commercial using. At first, we use a calculator to simulate the phase diagram of quaternary titanium-rich medium entropy alloys. It can be found that the microstructure of the alloys can present it as a single BCC solid solution. Therefore, based on the calculated results, the series of the medium entropy alloys from titanium 45 to titanium 80 were investigated. We can find that besides titanium 45, the compressibility of medium entropy alloys can exceed 50%. In addition, with the titanium content increase, the strength of the medium entropy alloys will decrease at the same time. On the other hand, for the structural materials, the tensile properties are more critical than compressive properties. Among of titanium 45 to titanium 80, titanium 65 presented outstanding tensile properties. The strength can reach 1,200 megapascal, and the ductility has 80%. Moreover, after homogenization heat treatment, the plastic deformation can be enhanced to more than 30%. Later, based on the titanium 65, we introduced the thermomechanical treatment in processing. The mechanical properties can be further exploited through a different amount of rolling processing and heat treatment parameters. In EBSD image, when the annealing temperature is performed at 500 to 600 degrees Celsius, the alloy cannot be recrystallized effectively due to the energy which is not enough. So a large number of the deformation bands will still be retained in the alloy. On the other hand, annealing in a high temperature with short time, the recrystallized grain can effectively nucleate and refine, which are about 70% smaller than the casting alloy. In mechanical properties, it can be noticed that the grain size here has little effect on the strength of titanium 65 medium entropy alloys. Besides, the time of the heat treatment plays an important role in plastic deformation. Among of them, the best heat treatment parameter is annealing at 1000 degrees Celsius for 3 minutes. The mechanical properties of titanium 65 can reach to 1000 megapascal and 30% elongation. Also, we use titanium 65 as a basis to further adjust the alloy system by adding vanadium. We still use calculator to simulate and predict a structure with different aluminum content. Then in the X-ray analysis, it is proof that alloy can maintain as the BCC phase, and it is also verified the result of calculator simulation. In the compression testing, the plastic deformation of each alloy can exceed 50%, and the strength enhanced with the increase of the aluminum content. However, in the tensile testing, the ductility of aluminum 12 is reduced significantly, while aluminum 18 is completely brittle fracture. In the third stage, we further discuss the parameter of thermomechanical treatment. It can be seen that grain size of titanium 65 medium entropy alloys are effectively reduced when the heating rate of the annealing temperature increases. Corresponding to the mechanical properties, the higher the annealing rate, the higher the alloy strength, which is confronted to the concept of the Hall-Page equation. Moreover, we exploited the mechanical properties under partial recrystallization situation. The strength of titanium 65 at 57 seconds and 65 seconds are increased 100 to 200 megapascal than homogenization, while the ductility does not reduce too much at the same time. By EBSD figures, it can be seen that the alloy is composed of retained deformation grain and fine recrystallized grains simultaneously. And this structure is also called a heterogeneous structure, which is the most popular subject in alloy research recently. In addition, we also use titanium 65 to carry out the research on commercial application of large-size alloy sample. We entrust the MIRDC to prepare the casting sample, while the hot forging was completed by Fidelity Aerospace, and the cold rolling was carried out in National Central University. Through EDES, we can see that the proportion of elements are close to the nominal composition after heat treatment or forging. And a stereo microscope was used to observe the surface morphology of alloy after hard forging. And you can see that there are no obvious defects on the surface after hard forging. Finally, we cooperated with FUTEX Industrial Company and successfully used the titanium 65 medium entropy alloys on the striking surface of golf cart heads.